This is an example of an application problem that utilizes rational expressions. An airplane flying against the wind travels 180 miles in the same amount of time it would take the same plane to travel 320 miles with the wind. If the wind speed is a constant 70 miles per hour, how fast would the plane travel in still air? So we want to find out in still air, the plane would travel how many miles per hour? To do this, we're going to need to utilize the distance equals rate times time formula. The distance traveled is equal to how fast you're traveling times the amount of time you're taking to travel. In our case, we're given distance, we're looking for rate, and the information about time is that the plane's flying with the wind and against the wind fly in the same amount of time. So I'm going to rewrite this formula in terms of t by dividing both sides by r. So the time is represented by the distance you travel divided by your rate or speed. So in this particular example, what I have is that their times are the same. So I will be replacing time with distance over rate. And now my job will be to fill in the information in both sides of this proportion. So again, I'm looking for how fast it would travel in still air. So that's going to be my variable x. Now, when you are flying, the airplane is affected by the wind. If it is pushing behind the plane, or what we call a tailwind, it's actually making the plane go faster. If there is a headwind, or you're flying into the wind, then that resistance of the wind actually makes the speed slower. So in terms of our rate, we're going to have our rate of x either plus 70 or x minus 70. So let's begin by taking a look at our mileage. So one plane went 180 miles distance, and the other one went 320. And so with x plus 70, that means the speed is faster. So the faster you're going in an amount of time, the farther you can travel. So the x plus 70 goes under the 320. Under the 180 goes the x minus 70. Since I'm not traveling as fast, I'm not going as far as I would in the same amount of time. So that's the setup of the application problem. Once you're at this point, it's a matter of doing your calculations. So we're going to cross multiply this. And basically, you're going to multiply 320 times x minus 70 is equal to 180 times x plus 70. We'll go ahead and simplify this equation. So 320 times x minus 70 times 320, 22,400, equal to 180x plus 70 times 180, 12,600. And simply solve for x. I will move my 180 over to the left, which gives me 140x equal to, adding the 22,400 to the other side, is equal to 35,000. So divide both sides by 140, and it turns out that our miles per hour is 250 miles per hour.